I am honored to be the guest speaker today to talk on this topic. So to go back to, what we've been talking about lately, cyber resilience is not the same thing as backup and recovery. The landscape has changed over time where it was all about just backup, DR, and that was, all everyone really cared about when it came to backup. But cyber's really become a big topic. That's why we're covering this topic again today. Some of this material that I'm starting with is the same as Marco covered, I think it was last month or a couple months ago, but it's really critical to understand, all the pieces around cyber and protecting your backups. So just to review a little bit, cyber resiliency is not standard backup and recovery. You want to have protection with TDE and key management. You want to encrypt your backups, transaction level protection. You want to check for anomalies, separation of duties. All these things were not necessarily part of typical backup and recovery, but they need to be there for cyber protection. And, ZDLRA, which probably, all of you already know a lot about, but it was designed for recovery. It's fast database restores, continued validation, it's resilient architecture, and those pieces really fit in well for cyber protection, and then fits into a cyber vault, which is a lot of what I'm going to talk about today with air gap protection, separation of duties, audit and compliance reporting. There's a lot of pieces that do help protect your backups. So, just a little bit of review again. ZDLRA has real-time transaction protection. So that is where it gets the transactions directly from the databases rather than just log sweeps. So it gives you a better recovery point. And then the incremental forever backups where you do the full backup once, and then it's just the change blocks. And then internally, the recovery appliance virtualizes it and creates that virtual backup, that virtual full. It has immutable backups, meets SEC regulations, and a lot of customers are looking at replicating into a cyber vault. That's what's shown on the right-hand side, which typically has some sort of firewall and protection around it. Archive to cloud. So, sometimes customers send a backup to immutable object storage in OCI as that protection from some sort of attack also. And the ZDLRA is a great way to take the backups that exist on it, dynamically create it, and send it to the cloud, make them immutable. Can also send those backups to ZFS storage. And the new space-efficient encrypted backups fits in great with encryption and compression and all those things that you want to have with your backups. So today I'm going to talk about air gaps. That's been a big topic. That's what a lot of customers have asked about, that is air gaps, and a lot of other vendors are talking about air gaps, logical and physical. So I'm starting with, Wikipedia is what is an air gap? And it's, network security that protects the backups or protects the system and isolates it from other systems. And in the case of cyber protection, you want to have backups that are protected from from the regular network in case there was some sort of breach. So on the bottom right-hand side, an air gap is, a physical separation of the network, complete physical separation. And the way we used to do that in the old days was tape. And that's what I'm showing on the left-hand side here, is a lot of times you would cut a tape and you would send it off-site, and that would be your air gap backup. So I went to NIST, National Institute of Standards and Technology here in the US. That's where I'm based. And what they define is a strict implementation of the air gap is that true complete cutting of the network and there's no traffic going in between them. But they also mention a less strict implementation where ports are down for most of the day and there is an opening for, typically a couple of hours during the day to send the backups, and then it closes again. So that's what they describe as a less strict implementation. And I know we've had sessions where we've talked about, how the recovery appliance fits into that kind of architecture. And what I'm showing here is typically what we would see: 2 data centers and a separate vault network in isolation with DNS, NTP, and a clean room. And then this is a diagram of what we see a lot of customers do is without the vault is primary data center, secondary data center. They're either replicating to the secondary data center or they're backing up local, and that's a secondary copy. But that may not be good depending on what happens with the attack. If the attack is to both data centers or it attacks the data in the database and that replicates or goes down to the standby database because it's more of a logical attack, then that goes to the secondary copy also. So that's where customers start looking at a vault with a timer where it's completely separated, it's hard to get to, and backups are sent periodically. But the issue with the physical air gap is, as I said, it's only open for a period of time during the day, which means that the point that you can restore to from that copy is older. It could be up to 24 hours old, depending on how often that air gap opens. But if it opens once a day, it's probably at least 12 hours old. So you have, guaranteed data loss. You've got protection, but you've got that data loss. The other thing about it is when we see customers put in some kind of vault system, they really limit the availability of those backups to the primary system. So typically the only network connection is the backup traffic that is replicating into the vault, and there's no path back. So those weren't necessarily sent there to be restored directly back to the primary systems. And in order to configure it to restore back to the primary systems may take some time. So really, they're not meant to be a high RPO, or a low RPO and a low RTO to really get back up and running. They're really meant as a last resort and a secure copy. And sometimes customers have a clean room and that's where they're going to bring their systems back to, or sometimes they're going to extract a subset of the data. But really they have that data loss, so they're not going to be your primary place you're going to go to restore from if you have to. So what's a logical air gap then? Because I hear that term a lot, a physical air gap and a logical air gap. And I went to Google and looked for their AI answer, and their answer is it's a network isolation technique that uses software and the configuration of the hosts and those strategies to protect a network connected digital asset. So it's not shutting down the network like a physical air gap does, but it's really a layered approach to separate and protect the backups as much as possible while still providing a low RTO and RPO. That's kind of the goal of a logical air gap. And that's what I'm showing here on the bottom of the screen is all the things that the ZDLRA does to provide that protection, with the mutable backups, audits, validation, segregation, policies, and I'm going to go into a lot of those pieces. So again, I turned to NIST, and the two things I could find is they talk about a logical isolation, and in that they mention using VLANs to separate the network traffic from, of your backups and that data from other data on the network, and encryption. Encryption is one of the most important things to make sure that you have in your environment. The other big piece of it is zero trust architecture. So that's the idea that there is no implicit trust and everything has to be checked and access has to be granted, and it puts a high level protection on the systems and the backups to ensure that they remain untouched. And what I find is that that's really the basis for a logical air gap, is to protect it as much as you can, and zero trust architecture is a great way to have standards and ways of protecting the backups so that you can use them in case of a cyber attack and they're not going to be touched. So the best practices for ZTA, and when they talk about that logical air gap, is you monitor and secure the assets themselves. You check users to make sure that they don't have privileges that they don't need. So you're limiting the privileges, and you're auditing and logging everything that they're doing. All communication is secured, which goes back to encryption. Individual enterprise resources granted on a per session basis. Roles and policies to control security, and microsegregation of both the network and accounts. So from the first part of it, where, to protect the assets and security posture, the recovery appliance is based on Exadata, the hardware and the software. And Exadata follows the, maximum security architecture, where it's hardened. You can see all the items that are on here to secure the Exadata. So a lot of focus went into securing the system itself and making sure that it's hardened and it's going to be protected from any sort of attack. And it's pre-scanned full stack, so before it goes out of the factory, it's scanned. There's continuous scans for it for vulnerabilities. The patching, so we have a very stringent patching process that we've been following for years, where as soon as something comes out that needs to be fixed, a vulnerability comes out, then there's a patch that's released, because we take advantage of that Exadata stack. So it's very well protected from that aspect, the asset itself. So the next piece is the users with special privileges. So there's a lot of separation of duty that happens with the recovery appliance to make sure that the backups remain protected. The first part of it is, on the left-hand side, you've got the DBAs. The DBAs have access to the database. They send the backups to the recovery appliance, but the DBAs do not have the ability to delete the backups that are on the recovery appliance, change the policy, or change anything to do with the recoverability of the database. They just send the backups to the recovery appliance, and they have access to restore them, but they can't do anything to damage those. The recovery appliance has an administrator, and that administrator takes care of the day-to-day management of the recovery appliance itself. So they are the ones that set those policies for protection, but they don't have access to the database. So there's a separation between those two. And then when a customer has a vault, a cyber vault, they have that second copy or third copy of the backups. That can be a different individual. And that's what the recommendation is to have a separation of duties between, the database administrator, the administrator of the recovery appliance, and then the person that administers the backups in the vault, so that if any one of those credentials gets compromised, it doesn't give you the ability to destroy all the other pieces. They're all separate, with separate people that have that separation of duties. The other thing is a user lockdown. So, a lot's been done to ensure that the recovery appliance is protected, the backups are protected, and changes to the recovery appliance aren't done without that being logged and without having a quorum on it. So that was something that came out in the last year, is the named administrator accounts on the recovery appliance and quorum-based approval. So to make changes to the recovery appliance that affects the backups, you need more than one admin to make that change. So someone requests it, and then you need two other admins to approve it. So that gives an extra level of protection of the backups in case an account gets compromised. And it's the same thing within the vault. And with the separation of duties, those could be different individuals. And then the last piece of that is the audit and logging. So there is internal auditing within the recovery appliance. So there's a API history. So all the calls that are done to make changes to the recovery appliance are audited with when it happened, who did it, what was the command. So all that information can be sent to an external auditing tool. So, we have customers that do that, check for any issues with what was done on it, and then you can alert on, any actions that should not have been done, and you have that log of what happened. So the next piece of it is secured communication. So this is really where the ZDLRA excels, because we're talking about encryption and sending the data over the network and making sure that that's encrypted. So it starts with TDE. So the first recommendation for securing your database is use TDE encryption. That's what we do in our cloud, and that encryption the backups get sent to the recovery appliance. And what the recovery appliance is now able to do is compress those encrypted backups and send them on to the recovery appliance as encrypted backups. So it decrypts them, it compresses them, it re-encrypts them, sends it to the recovery appliance, and we're still able to create an incremental forever backup of those databases. And this is something that is unique to the recovery appliance, because the problem with TDE encryption is it doesn't compress. And yes, you can use RMAN encryption to do something similar where it decrypts, it compresses, and it re-encrypts, but the re-encryption creates a new key, so you get no deduplication. So you really don't get both. But with the recovery appliance, you're able to get the best of both worlds, where it's still encrypted, but it's also compressed. And the backups stay encrypted throughout their life cycle. With that end-to-end encryption, the other nice thing about it is that it uses the encryption key that is owned by the database. So the database is the location of that key where it's stored. Each database has its own unique encryption key. And with multi-tenant, each PDB has its own unique encryption key. So even if an encryption key gets compromised, it really only affects a subset of the data, because they're tied to the database. They stay encrypted throughout the process where it gets sent to the recovery appliance, gets restored. The recovery appliance doesn't need the encryption keys in order to do what it does. And if you have non-TDE databases, you can go through the same process, send encrypted backups to the recovery appliance. It just doesn't do that decrypt process. It compresses it, it encrypts it, and then it formats it, and then does the incremental forever. And this gives you faster restore time because of the compression. So you're not sending as much data over the network. You're just you're restoring from a backup that is compressed. So if the network's your bottleneck, then that gives you an advantage there too. So the next piece of it is access is granted on a per session basis. And the way it works with the recovery appliance is it's not an NFS mount. And that's typically, where this becomes an issue. Because if you're sending your backups to a local location or an NFS mount on the database host, that mount is always available. So your backups are always available and visible from that host. There's no separation. There's no rechecking of the permissions that are granted. And the way it works with the recovery appliance is there is a library that is on the database host. It comes with the install of the Oracle software itself. You can download it from the recovery appliance also to make sure you have the latest version. But that library is what does the encryption and sends the backups. It sends them to the network, to the recovery appliance. And when you make the connection to send the backup, the access is validated at that point. When the channels are open, that access is validated. So if there is any sort of attack and you remove privileges from your databases, it takes effect immediately because any of the new backups are going to be stopped because it doesn't have the right access. So it's really important to have that separation where it's not a mount. You have the access checked every time you connect on that per session basis, and it gives you the ability to immediately revoke that access if you need to. And the next piece is role-based policies. So the recovery appliance has policies that control the retention of the backups, replication, what happens to those backups. And this is the idea of backup as a service, kind of like database as a service. So your databases, you typically group together as, critical, maybe they're dev databases, maybe they're not as critical. And on the recovery appliance, you set the retention and what happens, with replication and sending backups to other locations based on policy. So you'd create a policy for your critical databases, you add your databases that are critical to that policy, and then they inherit the characteristics of that policy. The other part that can be a characteristic of the policy is immutability too. So as soon as you add a database to be backed up to the recovery appliance, you add it to your gold policy or whatever it is that manages your critical databases. It immediately sets up the correct retention and the correct immutability for that database, and it's the same as all your other databases. So it gives you that central management point and ensures that as you add new databases to be backed up, you have that consistency, for all your database backups that are at that same level because they all share the same policy. So it gives you that nice management, and it ensures that the retention is correct for your databases. The last thing it mentions is microsegregation. And I tried to come up with a picture here. And one of the things with the logical isolation it mentioned is VLANs. And also I have in here is accounts. So one of the nice things about the recovery appliance is, the RMAN catalog sits within the recovery appliance, and it takes advantage of the fact that the RMAN catalog can support multiple users in the same catalog that only have access to a subset of the databases. And we see a lot of customers do this where they have multiple DBA teams, and those DBA teams manage a subset of the databases that back up to the recovery appliance. And we also see customers have VLANs, so they also have that separation. So if you wanted to, you could go to the level where I've got a database that is like one of my most critical databases. The people that manage it are just certain individuals. This is all they do because we really need to protect it. That database can have its own account within the recovery appliance so that none of the other, databases that are on the recovery appliance have access to those backups. And that can be on a separate VLAN so that the backups that are coming into the recovery appliance are isolated, and it separates those backups from each other. So there's a very high, a very detailed level of segregation that you can do on the recovery appliance, that microsegregation where, you could get to the point where each database has its own account with its own privilege just to see those databases. But typically what we see is grouping databases together where, there's an account that manages, the critical databases, the non-critical databases, and then separate VLANs because, oftentimes those critical databases are on a different network than the non-prod or the less critical databases. So that's what I'm trying to show here, is that there is a very high level of microsegregation you can do if you really needed to, and you can isolate everything down to whatever level, makes sense for your organization. So the one thing I didn't see when I look through NIST and what it talks about is the zero trust is immutability. And that's a big topic that we hear everyone talk about these days is, immutability is the idea that you lock your database backups and you protect them to make sure that they can't be deleted prior to when they expire. And that's what we support on the recovery appliance is you set a retention and for the example here it's 30 days, but the immutable window is 14 days. So that means that the backups cannot be removed for 14 days. The database cannot be removed from the recovery appliance if there's any backups that are within that 14-day period. So it protects the backups even from an administrator. No matter what your privilege is, you can't remove the backups that are marked immutable. So that's on the recovery appliance. The same thing happens within a cyber vault. So that's typically what we see when a customer has a cyber vault, is that they have an immutability window on their primary backup, and in the vault they have immutability set up on the backups that are in there. Oftentimes it's the same retention. In this case, it's 14 days and 14 days. Sometimes it's shorter, sometimes it's longer. It just depends on, the customer and how they want to configure it. Immutability can also be set up in OCI object storage, and it can also be set up on ZFS object storage. So we do have some cases where customers are sending a secondary copy of the backups from the recovery appliance to OCI and setting an immutability window on those backups, or sending them to ZFS as object storage and then locking those, setting immutability on the object storage on ZFS. But that's a critical feature, is immutability. And the place where the recovery appliance really shines also is anomaly detection. That's an area that you really want to take a good look at, is to validate your backups to make sure that they're good, valid backups. And it's a little bit different when you're talking about database backups than it is other types of backups, right? So a lot of times when I talk to customers, they're asking me whether or not the recovery appliance searches for ransomware signatures. That's a common question. But if you think about it, what a database backup, or at least an Oracle database backup is RMAN backup sets. We're not talking about libraries. We're not talking about executables and files. We're talking about RMAN backup sets. So it's really important to ensure that those RMAN backup sets are valid, RMAN sets that you're going to be able to restore and recover from. So one thing the recovery appliance does is, because we know what those RMAN backup sets look like, we know the format of them, we're able to validate them in transit as they get sent from that library. The library validates them. When they arrive on the recovery appliance, they get stored on flash cache. Then they get ingested, and that's how they become virtual backups. But it gets validated at that point too. So if something were to change the backup that got sent to the recovery appliance, it's able to determine that and alert on it. So there's checking on the recovery appliance for any sort of attack on the backup. It's revalidated on a weekly basis. So the backups, once they're sitting on the recovery appliance, they're also, validated regularly to make sure that they're still good, valid backups. That's one of the challenges of an incremental forever strategy. I know other vendors try to do something similar where they, do the full backup once, use that incremental merge that came about in 9i. But, you have to remember, because you're just sending over changes, you have to validate what you already have. That's critically important. And typically that means running a restore validate of your database backups on a regular basis to make sure they're good. That's what happens internally on the recovery appliance itself. It does that restore validate to make sure that what is on it are good, valid Oracle backups, and you're going to be able to restore and recover from those backups. And that works out really well with the Vault. So that's what you see here on the bottom in the right-hand corner, is with the Vault, the same thing happens on it. So when replication happens to a Vault, it's not replicating files. It is replicating the backup pieces. It's ingesting those backup pieces. It's creating virtual fulls, just like it does on the primary appliance that sent them. So it does the exact same validation, where it ensures that the backup pieces that are sent to it are valid Oracle backup pieces, and it's able to revalidate the backups that are on it on a regular basis. And that's really important in a Vault if you think about it, because if you have your backups isolated, with a Vault around it, you really need to, periodically do restore validates. And that copy in the Vault is going to be difficult to do because you're going to have to run a database host, because typically you're not going to access it directly from your primary data center. So the validation that happens in the Vault with the recovery appliance is really critical to make sure that the copy that is in the Vault is a good copy. Also on the top, if you do send those backups, that secondary backup to OCI object storage or ZFS object storage, it's validated when it's sent. So, it does that extra level of validation all the way through to check for any sort of anomalies so that you can be assured that the backups are good Oracle backups all the way through the process. So, to go back to physical air gap, where I started with, here is what I typically see customers do when they set up a physical air gap. So what you see on here is, in the middle, there's a timer, there's firewalls, the traffic that runs between the primary data center and the Vault really is the traffic from the upstream to the downstream and only certain ports. So the traffic is very, very isolated to just, that specific replication traffic. In order to get into the Vault, there's typically some sort of jump server where it's audited so that, anybody that goes into the Vault, what they're doing needs to be approved and gets logged. And within that Vault, we often see NTP, DNS, there's a clean room, there's a process to send outgoing alerts and audits in case something is caught in there. So, it works out really well, and the recovery appliance is a great fit for a cyber vault. But as I said, the problem with it is that the timer only opens up for a certain period of time. So you can see this is not where you're going to go to for your regular restores where you need to restore quickly because it's not some sort of cyber attack and you trust it. But this is for that last resort where you need to restore and rebuild the system either in the Vault or pull data from a backup in the Vault and bring it back. So ZDLRA in a physical air gap Vault, it supports optimized replication. As I talked about, is the replication is incremental forever. So it's just going to replicate those changes, and those changes are going to be compressed and they're going to be encrypted. So it's limiting the amount of data that is replicating into the Vault because it's just the changes, and those changes themselves are compressed, and they are encrypted all the way through, and it's still able to do that create that virtual full from it. As I mentioned, it does that validation, the check for anomalies within the Vault. So it does that restore validate on a regular basis, even within the Vault. The other thing I kind of brushed on is the RMAN catalog sits within the recovery appliance. So that means that the copy that is in the Vault, because it's on a recovery appliance, also has an RMAN catalog. So if you do need to restore and recover a copy back to your clean room within the vault, you don't have to, tell the database where the backup pieces. You don't have to catalog them or do anything to them. You just connect to the RMAN catalog that's in the vault, and you're able to immediately restore and recover using that RMAN catalog. And the RMAN catalog also gives you the visibility into the backup pieces and reporting as to what's available, what your recovery window is. So it gives you a lot of advantages in a vault situation with reporting and alerting, because the RMAN catalog and the recovery appliance knows what that recovery window is. So if you say it's 30 days, it can alert and tell you that within that vault copy, it has that 30 days of backups, and those backups have been validated. So those are great features, especially within a vault. So the problem with other backup appliances is that they do limited validation. The only way to validate the same way is to do a restore validate of the backups. The non-optimized data transfer, as I said, is compression and encryption, and incremental forever is, you have to pick two of those, but it's really hard to do them all like the recovery appliance does. Validating the DB backups requires database software. So the restore validate, you have to have, the database software out there in order to do that check. And you have to catalog the backups, and it's difficult to determine what the availability is for the backups that are sitting in the vault. And then I talked about, a logical air gap. And like I said, it's layers of protection and network segregation to give you as much protection as you can possibly do while still providing a very low RTO and RPO. And that's what I tried to show on this slide is, you have all this protection around the recovery appliance where, a full stack scan, auditing, logging, privilege control, integrity checks, immutability, encryption, that user segregation, the secure communication going from the database to the recovery appliance, and encryption starts with the database where the database holds the keys. So, that's the idea of a logical air gap where you're doing everything you can. And like I said, is, what I looked at was NIST and the zero trust architecture, because that has a lot of the pieces that you want to use in order to put in those levels of protection for the backups. So ZDLRA, in a logical air gap is it provides that near zero RPO using the real-time redo. If you're not familiar with it, the recovery appliance gets the backups directly from the database, just like a standby database. So you're able to get that, very, very low, near zero recovery point, even if, the database crashes, if the database is attacked by some sort of ransomware, the last valid transaction is sent to the recovery appliance, and that's going to be your recovery point, not the last time that you did a log sweep. It's able to do the incremental forever backup of compressed TDE data. Backup pieces are encrypted, and the encryption keys are held by the protected database, and they stay encrypted throughout their life cycle. And as I mentioned, we do that Oracle specific validation, and you get a low RTO because you're restoring compressed virtual full backups. And the nice thing about the virtual full too is that you are restoring back to when you last did an incremental backup. So your restore point is going to be less than 24 hours old. So you're not doing a restore back to, your previous full backup last weekend and applying incrementals. You're going back to that virtual full backup that is, less than 24 hours old and compressed. So it's less network traffic. So that really helps with the restore and recovery time of the database. So for other appliances, as I said, is the RPO, that recovery point is based on the last log sweep. regardless of what you do, there's still transactions that are in the redo logs that hasn't been sent. So what the recovery appliance does with the real-time redo, no other vendor can really do. So they're really basing it on, when they last did that log sweep to pick up the archive logs. The inability to optimize TDE backups, as I said, is, with compression and encryption, you can get deduplication, or, you can get deduplication, you can get compression, but you can't get both because RMAN does a new key. The validation of DB backups requires constant restore validates. So that's what you really should be doing on a regular basis, is doing a restore validate to make sure that your backups are good, especially if you're using some sort of incremental forever strategy where, some of those blocks have not been backed up for years even. You want to make sure that the backup that you have is good, and that that full backup set that you're going to restore and recover from is all whole and is going to work when you go to, do some sort of restore. So restore validate is critical to do. And they're going to have a higher RTO most likely because they're not utilizing those compressed virtual full backups. So, in summary, ransomware breaches, can be devastating. And the recovery appliance was built to give you the best protection for your Oracle database backups. And with the, cyber becoming such a big issue, all the features that it does, the validation, the real-time redo, the incremental forever, and now the compression of encrypted data really makes it the best way to ensure that you're going to be able to restore and recover quickly from some sort of ransom attack, or, no matter what the reason is that you need to restore and recover quickly. The recovery appliance is going to be the best, fastest way to, get back to business, no matter what the situation is that caused you to, do that restore and recovery. And then here's just some additional resources on this topic. There's, blogs on ransomware. So listed here are the blogs. And I know there's been some Ask Tom sessions recently because this is such a big critical issue that, that's why we've covered this topic a couple of times in a couple of different ways. So I think that's really what I had to cover today. And thank you for joining, and I think we can go to questions now.
Thanks, Brian. If there are any other questions, we've been answering questions in the Q&A as we've been going along. But if you have questions now, put them in the Q&A. That'll give us an opportunity to answer. A couple of questions that came up around the recovery service. So the recovery service itself is the recovery service is an offering in OCI, and it is essentially a giant fleet of recovery appliances that are managed by Oracle, and then connected to the OCI database services through automation. So a lot of these concepts around, configuring and keeping users separated, that kind of disappears in OCI because that's all done out of the box, if you will. There's always a separation of duty. The individual users do not have access to the recovery service infrastructure. You only get RMAN access in and out of the infrastructure. And I've done some previous Ask Toms where we've kind of gone through that. So look back at the history of recordings on the office hours, and you'll see some of those explanations.
And it does that same level of validation that I talked about, anomaly detection. And that's really critical for your backups in OCI also. That way you can be confident you're going to be able to restore and recover from them.
I want to thank everybody for joining. As always, if you have any topics that you would like covered in our office hours, please give us feedback on the office hours website, and then we can cover that in future sessions. There's a question about documentation to use ZDLRA from an Azure instance. So that's cloud to on-premises, which isn't typical. There is the recovery service is exposed via the Oracle database at Azure offering. So if you go to the Oracle database at Azure, the recovery service, which is the recovery appliance in the cloud, is a destination that you can select for backups. So cloud to cloud, I don't see a lot of customers typically going cloud or cloud to on premises. It's kind of a backward paradigm. Most everything goes toward the cloud. All right. Thanks so much, Brian. It's great having you with us
Thank you.
today.
It was a pleasure being the guest host today. Thanks.
Thank you so much. Yeah, that's great. Thanks, everyone. Have a wonderful weekend, and hopefully we'll see you on an office hours in the future.